See that?
So what is going on here?
Okay, the soil does not have a strong enough electrical charge, a static charge, to function as a humectant on its own. The charge has to be a negative charge. If it had a strong negative charge and water having a positive charge, the soil could attract the water and it'll get wet. In this case, the soil is hydrophobic, or suffering from what we call hydrophobicity. This is the same thing that happens on a forest fire site when the organic matter of the vegetation, when it's on fire, it turns into a gas. When the gas cools, it settles down into the soil and makes the soil waterproof, or hydrophobic. So one of the big problems with agriculture and even landscaping in the Southwest is our soils are hydrophobic. Maybe not as bad as this, but nonetheless, they don't want to get wet. And so if I can add something to make the soil more receptive to the water, in this case it would be the carbon matrix of our product called TerraPro, then that would break the hydrophobicity and help water absorb into the soil and stay there. So one of the characteristics of the carbon matrix, based on the research that we did with the help of the national laboratories, Sandia and Los Alamos, where we did a molecular characterization research project, is that we discovered that this carbon matrix of nature is a natural humectant, something that can attract water. When we put it into agricultural soils, we see an amazing improvement in the drought-tolerable limits of the crop. In some cases, as much as 70 to 80% less water is needed to grow that crop because we added the carbon matrix to the soil. So this just exemplifies what hydrophobicity is. If I were to treat this site with the carbon matrix, I would soon see this problem disappear.
Okay, so very commonly people would take soil like this, for instance, and add organic, potting soil or compost to it, and they think that that would actually solve the problem for them in terms of getting this soil to be more rich for potting and so forth. What is it that would not make it happen that way?
So the assumption is that by adding organic matter from compost or peat moss or potting soils, that you're going to make the soil better at holding water or attracting water. But let me ask the question, how many of us have had a house plant that we allowed to get too dry? We went away on vacation, and when we got back from vacation, the plant was dying because it was droughting out. And when we went to water the house plant, the potting soil, which is 100% organic matter, actually repels the water. Many of us have seen that, and the reason why it's repelling water is that organic matter is naturally hydrophobic. It's not hydrophilic. It's the opposite, hydrophobic. So if you let it get too dry, it's going to actually cause an even bigger problem. So adding organic matter to this isn't the way to solve the problem. Organic matter has a very, very low electronegativity factor. In other words, the static charge, negative static charge of organic matter is extremely low. Therefore, it doesn't attract moisture. It does the opposite. It repels it. So we have to add something to it that's going to attract moisture, and that's the carbon matrix that'll do that. I could use a detergent like ivory soap on this, and it'll break the surface tension of the water, and the water will penetrate the soil, but I'm not solving the problem. I'm only covering up the symptom. And so as soon as the soil dries out, it's right back to the square one, hydrophobic soil. So in agriculture, they sell surfactants or wetting agents to get the water to penetrate the soil, but that's not the solution. The solution is to go back, observe how nature works. Nature builds a magnificent biological chemical called the carbon matrix, and that is what solves this problem. And that's what we're able to do at Soil Secrets.